Okay, the next problem asks you to indicate what the coordinates of a point would be if you started at 5, 9, 6 and moved, well, if the initial point of the vector TV was at 5, 9, 6, what would the terminal point be? I didn't say that real well, but you get the idea. The initial point of TV is at 5, 9, 6. What's the terminal point? So the terminal point is, of course, here at the head of the arrow. The initial point's here. And V is the vector that we found here, which in this case would be 8K. So TV would be T multiplied by 8K. So that's just 8TK. So the vector is now, TV is the vector 8TK. If we have initial point 5, 9, 6, and we displace through the vector 8TK, where are we? Well, the three coordinates will be what? 8TK changes our z-coordinate by 8t. So our z-coordinate starts at 6, and we change it by 8t, so we end up at 6 plus 8t. Okay, so, and we have 0x and 0y component to this vector, so that when we move along the direction of this vector, we're not moving at all in the x or y direction, so that x and y stay the same. So our point is going to be 5, 9, 6 plus 8t. Now we go a little further with this idea, and I've redrawn the situation. 5, 9, 6 is going to be here. In V, now we're looking at this same vector from a different perspective, and the V vector might go in this direction. And there's no reason that the vector should be in one direction or another, because we're just using our diagram as a schematic. We actually know that the V vector is vertical, so we could have drawn it in the vertical direction. But we're representing everything in a two-dimensional plane, and our coordinate system could be rotated or tilted any way we wish, so that V might well look like this, according to some rotation of the coordinate system. Okay, well, don't need to worry about rotation of coordinate system just yet, but it's okay. So we're depicting 5, 9, 6 here. We're depicting our V vector here. It's not in the same direction as I depicted it here, and not in the same direction as was depicted here. But again, we're just maybe looking from a different perspective, and really just drawing a schematic. Okay, so here's our initial point. Here's our V vector. I asked you to indicate the point that we would be at if we started at this point, if our initial point was this point, and our vector was negative 2V. So what's negative 2V look like if V looks like this? Well, if here's our vector V, and somebody just said, well, it's a vector that's got twice the magnitude in the opposite direction. Well, everybody should know that, and that's true. So we simply draw a vector of twice the magnitude in the opposite direction. Now if we do that from this point, twice this magnitude in the opposite direction, we end up with the terminal point here. Okay, then you're asked to do this for a vector that's for the vector negative 1 times V, and we're phrasing this as negative TV for t equals negative 2, negative 1, negative 1/2, 0, 1/2, 1, and 2. Okay, so if t is negative 1, so we're going to move TV for t equals negative 2, negative 1, etc. This is, of course, in the statement of the problem. So again, if t equals negative 2, TV is negative 2V, we're going to move there and we're going to be at this point. So we could say that's our t equals negative 2 point. Okay. If t is negative 1, well, that's going to move us along the line of v, but in the opposite direction, and without changing the magnitude, because -1 v has the same magnitude of v. In other words, we just do the vector -v, and that gets us, let's say, to this point. There's our t equals -1 point. Okay, t equals -1/2. Okay, if t is -1/2, then we have a vector -1/2 v, and that has the direction opposite v 1/2 the length. Well, that's going to put us here. So here's t equals -1/2. And then t equals 0 is going to be here at our 0.596. Because if t equals 0, we're adding 0v, which is just 0 to our point. And then if t equals 1/2, we're here, t equals 1, t equals 2. I'm not going to label the t equals 1/2. I don't really have a good place. I could try to slip it in there, but let's not confuse the issue. Okay, so what do we see about these points? Well, our motion in this direction always has to be in the same direction as v. Our motion over here is always in the direction opposite v. So all these points are going to lie along the same straight line. And now we want to write down an equation or something that represents this straight line. So what we do is we think of the point 596 as being the terminal point of a vector whose initial point is the origin. So if our initial point is the origin, to get to 596, obviously, we have to use the vector 5i plus 9j plus 6k. Might be a little hard to read, but it should be obvious. This is it in a little better, well, just a little bigger and a little clearer. Okay, so this vector takes us from the origin to 596. If we then add tv for maybe one of these t values or maybe some other t value, where do we end up? Well, we end up at whatever the terminal point of tv is. If t is 2, then we're going to end up twice as far out in this direction. If t is 1, well, we end up here. If t is 1/2, we end up here. If t is -2, we end up twice the length of v in this direction, maybe here. T equals -1 here, t equals -1/2 here. It should be obvious that if t takes all possible values from -infinity to infinity, that we trace out this whole straight line, the straight line that has the direction of the v vector and passes through the point 596. And the vector that takes us from the origin to the tip of the v vector, in other words, the vector that really gives us the position of the point on the line corresponding to the value of t, is just the vector 5i plus 9j plus 6k plus tv, whatever tv happens to be. So if we add this vector to the tv vector, we get a vector from the origin out to some point of this line. And if t goes from -infinity to infinity, the terminal point of t will trace out the entire line from infinitely distant in this direction to infinitely distant in that direction. Okay, or at least a distance exceeding all bounds in each direction. I don't want to be too technical. Okay, so we need to have that picture for a straight line.